So this video is going to be about centroids and orthocenters. And the first page is going to be pretty easy. There is a second page that gets a little bit tougher. Okay. Just to warn you. So the first part, we have the concurrency of medians. We said that medians start at a corner of the triangle, okay, and go to the midpoint of the opposite side. So you'll notice, first of all, that we have all those congruent pieces just based on the medians. So AE congruent to EC, CD congruent to DB, AF congruent to FB. Okay, so when you're dealing with medians, that is one thing that you should be looking for in the picture. You know that when we have this, they're going to, the separate pieces on the same side will be equal to each other. Okay. I do want to note, we've talked about this before, but when we have the concurrency of medians, that is called the centroid. Okay. But now when we actually have, if we look at the medians themselves, when they intersect at that centroid, but it cuts those medians into pieces where there is a specific relationship. And there's a couple different ways of thinking that relationship through. So it tells us that AG, which is the bigger part of that median, okay, the respective part on the other side would be GD, which is smaller. Okay, but they are telling us that AG is 2/3 of the whole median, the whole AD. Okay. We could also say that GD is 1/3 of the full AD. Okay. What we can also say, I tend to usually think of this way that I'm going to do now. Okay. The smaller piece, sorry, the bigger piece, AG, is double the smaller piece. And then we can think of it in reverse as well. The smaller piece is going to be half of the bigger piece. Okay. So like I said, I tend to use these more so than the 2/3, 1/3. I mean, we might need the 2/3, 1/3 sometimes. Okay, but when you're looking at a median, okay, and you see the two pieces, know that the bigger piece is double the smaller one, or the smaller one is half of the other one. Okay, that's the main relationships that are going to happen here. What happens with the sections of the medians, and also the fact that because they're medians, the opposite side has been cut into two congruent segments as well. Okay. Um, Altitudes, okay, not a whole lot to talk about there, as I mentioned in the other video. When the altitudes intersect, that is called the orthocenter. Remember, altitudes are perpendicular and they start at the corner. Remember, perpendicular bisectors don't have to start in the corner of the triangle. Altitudes do, but they are perpendicular. Okay, so they might not necessarily be cutting the other side into congruent pieces. It is strictly forming a 90-degree angle with the opposite side. Okay, so the orthocenter, that's really all that happens. No, there's no segment relationships we can find here. I mean, maybe the only thing that can really happen, because this is a 90-degree angle, maybe they give you some sides of one of those tinier triangles that formed. But not, and that's really just using Pythagorean theorem at that point. But there isn't anything really special about the center itself. Okay. Similar to our circumcenter that we started with the other day, there's different places the orthocenter can be based on the type of triangle that we are dealing with. In a cute triangle, the orthocenter is going to be inside the triangle. In an obtuse, I'm going to the one on the right-hand side, it's actually going to be outside of the triangle. And in a right triangle, it's going to be actually the vertex of the right angle. Okay, so the orthocenter will actually be at the right angle itself. Okay, so just a couple quick questions to do, like I said, with the centroid, not with the orthocenter. So we have at the bottom here, what is JN? And I'm looking at this and I see these are congruent and those are congruent and those are congruent. So I know I am dealing with medians here. Okay, so we're dealing with a centroid. And if we have a centroid, the bigger piece, JQ, is going to be double the smaller piece. So QN is going to be 9, which means JN is the entire thing, and JN is equal to 27. That's it. Okay, the one on the side, it also tells us that we are dealing with medians. So it says find EV if BT equals 5. So right here we have 5. That is the smaller piece. We can decide smaller or larger. Okay, so this is the smaller piece of it, which means EV is going to be double that. So EV is 10. Okay. And then if FR, which is the entire median, if FR is 20.1, what is the measure of VR? Well, VR is the smaller part. Here's where maybe we use that 1/3. Okay, so we would find 1/3 of 20.1, okay, which is really just 20.1 divided by 3, and that is going to give us 6.7. Okay, that's that. So now the slightly harder ones. Okay, these are giving off the same vibes as when we did distance between parallel lines, and I know you love those. Um, but really, I want to stress that when you are doing these questions, take a pause and think about what information you are being asked to find, and then therefore what information will be important to find those things. If you pause and take a step and think what you really need, that should give you the steps of what you need to do here. Okay, as opposed to just trying to like wing it or memorize exact steps, okay, which can get a little bit crazy. So here it's asking for the centroid. We do need to make the connection, okay, that centroid is talking about medians. And if we are dealing with medians, that's starting at one corner and it's going to the midpoint of the opposite side. Okay, so what we really need to do here is find, I said medians again, but we need to find midpoints. Now, luckily we have a graph and we can kind of just figure out the midpoint based on the graph. Okay, I only need 2 of the 3 medians because what this is actually going to turn into is another system of equations. Okay, so we only need to focus on 2. So here is the midpoint of AC. Okay, this here would be the midpoint of BC. Okay, and then the midpoint of that would be right there. So I can decide which ones I would like to use. Okay, I'm going to first of all use, here, I'm going to color coordinate. I'm going to do this one right here. I'm going to fix that to make it look a little straighter. So this one right here. And the reason I'm doing that median, which comes from the corner C to the midpoint of the opposite side AB, because that's a pretty easy equation to write. Okay, so for AB, we'll say the midpoint was 2, 4. The equation, if it's a vertical line, we need to know that it's going to be x equals a number. Specifically, in this case, the equation is x equals 2. So that is the equation of the median going from C to AB. In fact, I'm going to change this slightly. Okay. I'm going to say that this is angle C to segment AB. And the midpoint, just to keep our notes a little bit more organized, our midpoint was 2, 4. Okay. And then we can do one of the other ones. It should not matter. Maybe one looks easier to you than the other. I'm going to choose to do this one right here. Okay. So this is going from angle B to segment AC. We know the midpoint. We said that was 1, 3. And now I need that equation. Well, I have 2 points on that line, the corner of the triangle and the midpoint we just decided upon. I could figure out a slope, and then I could use that information to figure out a y-intercept. That's our thought process here. Okay, I need the equation, so let's figure out what it is. So for my equation, My slope is going to be negative 1/3. Okay, I'm going to use 4, 2. It doesn't matter which one you use, though. You could use the 1, 3. Okay. And then either plug things into y equals mx plus b or do point slope form. I feel like I've been doing y equals mx plus b a lot, so I'm going to do point slope form. So y minus 2 equals negative 1/3 times x minus 4. And if you are not a point slope form person, feel free to ignore me right now and find a missing b on your own and just make sure it matches in the end. We would distribute here to get negative 1/3 x plus 4/3. And then we would have to add the 2 to both sides. And then because that's thirds, I'm going to automatically change my 2 into 6/3 to make it a common denominator. So y equals negative 1/3 x plus 10/3. So we are going to take those two equations. We'll call it orange. We're going to take those two equations and we are going to solve that system of equations. And this one's actually a little bit easier of a system because one of our equations is just x equals 2. So that's nice. Okay. So our system of equations, I'm going to do that over here. So here, if x equals 2, we can use substitution to solve this. So really, I'm going to start with that bottom equation, y equals negative 1/3. Instead of saying x, I'm going to plug in that 2. So negative 1/3 times 2 plus 10/3. And then I do that little bit of math. This would be negative 2/3 plus 10/3, which is 8/3. So that means that our median, or sorry, our centroid, okay, where those two medians intersect, the x was 2, so we know that, and the y is positive 8/3. That is our final answer for the centroid. Okay, and once again, centroid was medians, which meant we needed midpoints. Okay, once we knew midpoints, we could write equations for 2 of the 3 medians, and then we are solving that system. Okay. The last one is orthocenter. So orthocenter, we need to make the connection that we are dealing with altitudes. Okay, which means perpendicular lines here. Okay, so it's coming from a corner of the triangle to the opposite side, but it's hitting the opposite side in a way that is perpendicular to it. So in this, we are going to figure out the slope of the side, which will then give us a way to find the perpendicular slope because we can do the opposite reciprocal. And then we will use that information to write our equation. So let's focus on, we'll do, is this of a point? Yes. So this is K, angle K, to side ML. Okay. So something like this. It's not going to be perfect, but just to give us a general sense, it would look like that. Okay. So the slope of ML, that looks like it's going down one right, and that continues down. So our slope for ML is negative 1, which means the perpendicular slope is going to be positive 1. And because it's coming from K, which happens to be at the origin, okay, our B in this case is 0. So the equation for this one is just y equals 1x, or just y equals x. Our other one, let's do, remember, it does not matter which one we choose. I'm going to choose to do this one. So it'd be something like this. So this is angle M, this side KL. We need to know the slope of KL to start with. So it went up 5/10, which means our slope is 1/2, which means our perpendicular slope will be an opposite reciprocal, which is negative 2. And we know it came from point M, so I can use that ordered pair in order to find my missing y-intercept in this case. So for this one, I'm going to plug in things to y equals mx plus b. Okay, so our m was -2, our x is 3, our y is 12. We go from there. We get 12 equals -6 plus b, and b equals 18. Okay. So our equation for this one is y equals -2x plus 18. And now I have my two equations. We had y equals x and y equals -2x plus 18. Those are the equations of two of my altitudes. Now I will solve the system. Okay. Here, they're both y equals. So I'm going to say the x from the one is going to equal the -2x plus 18 from the other. Let's move our x's to this side. 3x equals 18, and x is 6. And because y equals x in our system, if x is 6, y is also 6, which means our orthocenter is 6, 6. So once again, for this one, okay, they have the altitudes, which means they're perpendicular. So find the slope of the original side, do the perpendicular slope, and go from there.